Alright, so for tutorial 2, I've brought in some ramen for consumption, just to make this a little more relaxing. Yum. If this video gets 10 likes, I'll make a ramen tutorial. With ramen at my side, no one can beat me. So with that, let's make our compile script to start off this tutorial. So we're going to start by creating a little folder. So folder project. Oops. Project C++. There we go. And from now on, this project folder will be where we store our stuff. So in this folder, we're going to hit a new, we're going to say new, and we're going to say text document. We're going to just name this compile.ps1. That's a PowerShell script. So we're just going to double click. No, we're going to edit with Notepad++ for ease of use. Alright, with our script open, we're just going to say a few things. We're going to go like this. We're going to echo compiling. And then we're going to say G++ -O for output. And we're going to say output, or we're going to say, yeah, output. And this is just the file name that we're going to output. And then we're going to pick our file name, which is going to be main.cpp, like so, just like so. And then, you know, before this, we're going to go std equals C++ 17. And you know what? Actually, not to save it quite that. After this, we're going to go pause. That'll complete our compile script. So with that out of the way and our compile script ready, we are ready. So right click, new, brand new file. We're gonna rename this. We're gonna say main.cpp. And we have a C++ file now. We're gonna right click and we're just gonna open with, and we're gonna see if we can open it with Atom right here. So Atom is my IDE of choice. It is indefinitely better than all other IDEs, and that is just a fact. Fight me. And without further ado, let us begin sharp include. And so here we go. The sharp symbol means it's a preprocessor directive. That means the compiler will look at that and say, I'm going to pull something in, I'm going to do something, I'm going to check something. That's what it's for. So these do not run. These are not cycle commands. You cannot put them in a loop. They only run in your compiler as you're processing. So it's a preprocessor directive, and we're going to include something. So there's a series of C++ libraries. The one we want right now, and I will link the C++ reference in the description below, so that you can check all the libraries out yourself. There will be another tutorial coming up later, checking how to properly interpret documentation. So in this one, we want to put the IO stream. I for standing for input, O for output, and this is stream as in stream of conscious, stream of thought, and it's just that's the name of the library. So with that out of the way, we're just going to go down, and our next one is going to be using. This sets a standard in namespace, or it's really just a property, using as a directive. So using namespace and then this lets us remove some annoying things from the namespace. So normally I would have to write std : cout by saying using namespace std, putting a semicolon. I no longer have to put this std before cout. So that'll tie in later. So using namespace std, and then we're going to say int main. So an int. So yes, int is a data type. It's an integer. That means a number without a decimal, and main is the directive the compiler looks for to start out the program. Main is the first called upon thing. I think there's also one called WinMain, but it's Windows specific, so we're just going to use main, and then we're just going to put a pair of brackets here. Brackets can be used to pass stuff in. We'll get into that in a later time. And then these curly braces, which open and close the basically are what we want inside of main. So when main concludes, it needs to output a number. So in this case, I'm going to say return, and I'm going to say 0. This doesn't mean anything. We're just outputting a number so that when the program exits, the integer is concluded. So our program is going to start and always will be executed from int main. It has to be an int. We're not going to use a double. We're not going to use a void. We're just going to use an int. So this inside, I should mention Whitespace does not matter except for things like this, like using space, namespace. But I can have multiple spaces. It doesn't really matter. Tabs aren't qualified, and so on and so forth. So anyways, so inside of here, we're going to say C out, and that is going to be pulling a definition from the I/O stream, and then we're going to pass a value into it. Rather than putting something in brackets, we're going to just pass a value with two of these, I want to say, directional symbols. This is the symbol for less than. Or if there's two of them, it means you're passing it into something or out of something. So pass, and I'm going to put quotations, and I'm going to say hello world. Hello world is a string, and string means string of text, and we're just going to say this, and then we can put a semicolon here to end it. And this is our very first C++ program. So if we go back to project, see our compile.ps1, we're going to right click on this, we're going to say run with PowerShell. Compiling, press enter to continue. So now we have output.exe, and that's going to run and instantly shut because there's no criteria for it to stay open. So what we're going to do is we're just going to hit shift, right click, and we're going to say open with PowerShell window here, and we're just going to say output.exe. And that is because it was not, we typed that wrong. We're going to put a dot backslash output.exe. There we go. And as you can see right here, it says hello world, and that's because C out means console output. So it's only going to output in a console-based directive. We can expand on this though. We're going to need just another library for this. We're going to say sharp include, and then we're going to include a C library. This one is going to be C stdlib, and this is just going to give us access to some system stuff. And the one I want to use is called system, and inside of system I just want to put the word pause. System calls a command line directive. So if we use cmd and type the command pause in, it says press any key to continue. We're just going to hit that, and this is not a cross-platform option. If you're on Linux or Mac, you should check your own options for that, but for me, I can use pause. And if I save that, and I then compile again, so I'm going to right click on compile.ps1, and I'm going to say run with PowerShell. It's done, and I'm going to hit output.exe, and as you can see, it says hello world, press any key to continue. Now you'll notice they're on the same line. There's a very good reason for this. So if we hit any key, the program ends, we're done. But we want to fix this so that system, where it says pause, ends up on a new line. So after this, I'm just going to put 2 dashes, and I'm going to say end L. This ends the line. So I should mention that if we want a line to exist but not to call it, just put 2 forward slashes before it, and that turns it into a commented line. This is what we use to describe code. It's not an executed command. So if I remove this, there's a few things we'll have to do. We'll have to say std, put 2 colons there. We'll also have to put the same thing in front of end L, and in front of system. We don't want this. This is inconvenient. It takes time. That's why we have namespace in front of here. Different libraries sometimes have different namespaces. There's a library called Chrono with its own namespace, and threading libraries also have their own namespaces. So we'll get into that in future tutorials, but I just want to make that note. So if I compile this, and then I double-click output.exe, as you can see, press any key to continue is on a new line. Now I can actually expand this term here, so if I wanted it to skip 2 lines, put another one, I'll say and L. You can actually stack this up as much as you want. It's a very, very useful tool. So, see, now there's a gap. Now, in some other tutorial series, you'll see people using a library called sharp include cstdio, or you'll often see them type in stdio.h. H means header. That's just the name of, but by saying cstdio, we can actually skip this .h necessary business, and we don't have to deal with any of this lame header stuff. cstdio is old. It is C code. So while we are going to be learning C++, in the process we're going to be learning C at the same time. 2 languages in one. It's pretty great. But this is old code. We don't want to use this if at all possible. That's why we use IOStream. cstdio.h gives us access to things like printf. Printf is a whole manner of times less secure than cout. In fact, using any C library is less secure. Even using system here is, because it's a C library, is not as secure as using proper C++. So it's highly recommended that if at all possible you can avoid using a C library, that you do so. That being said, C++ and C work coexistingly. Oftentimes there's no choice but to use a C library. C++ uses a lot of C libraries in its mainstream. However, just for quality's sake, we're going to try to use C libraries as much, or sorry, C++ libraries as much as possible when doing these, when writing code. Printf works within brackets. You input into the brackets and it outputs into the console. Cout, you have to pass information into cout. Cout itself is a variable. So, with all of that covered, that's going to conclude the very first tutorial. In the next tutorial, we're going to go over data types. That's integer and strings and booleans and stuff like that. I'm going to go through the whole list of what they are, how they work, and yeah. So if you like this format tutorial, leave a like and subscribe. I'm going to be doing more tutorials like this as time moves on, and I hope to keep these relatively consistent. Thank you so much for watching. Whoa, that is spicy. Whew. Whew. Less cayenne next time.